In the today's session, we will find roots of the algebraic equation by Newton-Raphson method. This is the part 3. Part 1 was of bisection method and part 2 was of regular falsi method. With the help of those two methods, you will definitely understand this third one. Let us take the first example. Find approximate root of x cube minus x minus 1 is equals to 0 by Newton-Raphson method. We have to only find up to 3 iterations. So solution is, consider f of x is equals to x cube minus x minus 1, which is the given equation in the question. Now replace x with xn and the equation becomes f of xn is equals to xn cube minus xn minus 1. Now find the derivative of both of this. So f dash x becomes 3x square minus 1 and in place of x xn, so f dash xn becomes 3xn square minus 1. The derivative is the differentiation, that is d by dx. So d by dx of x cube is 3x square. D by dx of x is 1 and 1 is 0. So the equation comes like this. So let us find the nearest root by putting approximate value of x. As in the two methods before we have solved, we have to find the two values of a and b. One should be positive and one should be negative. We have to find the values by putting 0, 1, 2, 3 till we get the two opposite values. Here f of 0 is negative 1, f of 1 is negative 1, which are both less than 0. F of 2 is greater than 0, that is 5. So f of 1 is less than 0 and f of 2 is greater than 0 have opposite signs. So we need to write, therefore the root of the equation f of x is equals to 0 lies in the interval between 1 and 2. So for the next step, take the value which is nearest to 0. Nearest to 0 is of minus 1, that is 1. So in the case f of 1 is near to 0, hence consider x0 is equals to 1. We have to find x0 first. Here we consider x0 is 1. So by Newton-Raphson method, approximate value of x is, this is the formula, xn plus 1 is equals to xn minus f of xn upon f dash xn. This is its own formula. So by substituting the value from equation 1, we get xn minus xn cube minus xn minus 1 upon xn square minus 1. This both the values are of f of xn is this and f dash xn is this. So after solving, we get xn plus 1 is equals to 2xn cube plus 1 upon 3xn square minus 1. This value, we are going to use it in all the 3 iterations. Okay, give it equation number 2. All the 3 iterations depends on this equation. So you need to find the correct equation. So put n is equals to 0, 1, 2. We have taken xn, right? So in place of x, we need to put 0, then 1 and then 2. So we get approximate root of equation f of x is equals to 0. Let us see the first iteration. Put n is equals to 0 in equation 2. It gives, take initial root calculated previously. We have taken x0 is equals to 1 as it was the nearest value to 0. So x1 becomes 2x0 cube plus 1 upon 3x0 square minus 1. After solving, we get the value of x1 is equals to 1.5. This was the value of x1. Now this x1 will be used in the second iteration. So put n is equals to 1 in equation 2, we get x2 is equals to 2x1 cube plus 1 upon 3x1 square minus 1. After solving, we get x2 is equals to 1.3478. See here, we get x1 value is used in this equation. So third iteration, put n is equals to 2 in equation 2, we get x3. So it was xn plus 1, right? So n plus 1, 2 plus 1 is 3. That is why we got x3. In the same way it was for the other 2 iterations. Here after solving, we get x3 value 1.3252. So after third iteration, the approximate root of the equation x3 minus x minus 1 is 0. So the final answer is x is equals to 1.3252. Even if it is not clear yet, let us take the second example. Another example. Find approximate root of equation under root 10 by Newton-Raphson method. Up to 3 iterations. Let x is equals to root 10. As the equation is not given, so we need to consider one value. Take x is equals to root 10. So x square is 10, that is x square minus 10 is equals to 0. Here x is 10 is positive. After going to the left side, it becomes negative. Now, f of x is equals to x square minus 10. Equation we have got. So now, put f of x is equals to x square minus 10. Therefore, f of xn becomes xn square minus 10. Now the derivative of this, we get 2x and 2xn. Since root 9 is 3 and root 16 is 4, where root 10, it is near to 3. It is not the equation given to us, so we need to get the values of nearest point. So take initial root x0 is equals to 3, as root 9 is near to root 10. So by Newton-Raphson method, approximate value of x is given by, this is the formula. After substitution of f of xn and f dash xn, we get this. And after solving, we get the equation number 2, that is xn plus 1 is equals to xn square plus 10 by 2xn. This equation will be used in all the 3 iterations. So put n value is equals to 0, 1, 2, we get approximate root of equation f of x 0. So if we put here 0, here x0 plus 1 becomes x1. If we put 1, x1 plus 1 becomes x2. And if we put 2, here x2 plus 1 becomes 3. So we get x1, x2 and x3. And here 1, 2 and 3. X of 0, x of 1 and x of 2. So let's see the first iteration. Put n is equals to 0 in equation 2. We get x1 is equals to x0 square minus 10 upon 2x0. After solving, we get the value of x1, that is 3.1666. So now the second iteration, x1 value will be used here. See here x1. Putting n as 1, we get x2. After solving, we get x2 is equals to 3.1622. Third iteration. Put n is equals to 2 in equation 2. We get x3 is equals to x2 square plus 10 upon 2x2. After solving, we get the value of x3 as 3.1622. So, after third iteration, root of the equation f of x is equals to x square minus 10 is equals to 0. That is, root 10 is x is equals to 3.1622. This is the final answer. I hope you understood.